Morning, 6th grade. Welcome to Investigation 10. We're going to learn how to use a compass and a straight edge. This is part 2. Why is it part 2? Because of what it says right here. Investigation 2 showed you how to use a compass to draw circles and a straight edge to inscribe a regular hexagon and a triangle and a circle. So if you remember way back months ago, we would draw a circle, then we'd do 12 o'clock, 2 o'clock, 4 o'clock, 6 o'clock, 8 o'clock, 10 o'clock, connect those dots. That would have been a hexagon. If we went from 12 o'clock to 4 o'clock to 8 o'clock back to 12 o'clock, that would have been the triangle if you skipped them. This investigation will show you how to bisect. Bisect means cut in half. A segment and an angle, and how to inscribe a square and an octagon in a circle. You need a compass. Yay. You need a ruler or a straight edge. Yay. You need a protractor. I don't have one of those. To construct means to use a compass and a ruler to make a geometric figures. Use a separate sheet of paper for constructions. Label the constructions A through D. Attach the paper to this investigation sheet. Okay, we are going to bisect a line. To do that means we're going to construct a perpendicular bisector to divide the segment in half. It says use a metric ruler to draw a segment 6 centimeters long. Whoop! They did that. Label the endpoints AC. They did that. Set the compass at 3.5 or 1.5 inches. This is a little larger than half. So what I'm doing here, guys, is many of us would say if I need to draw a segment 1.5 inches, I'm just going to use a ruler to do that. In math class, we normally don't do that. So guys, I made this a little bit more than a half. Then it says place the pivot point of the compass on endpoint A or C, draw an arc through the segment. Place it on the other endpoint, draw another arc, then draw a line through the 2 points where the arcs intersect. This line divides AC into 2 equal parts, label the B. So they did it down here, guys, at the bottom of your page here. Swung the compass on one side, switched to the other, swung it the other way, go through that. I'm just going to show you up here what they did. So I put my needle on C, and I draw, I put my needle on C, and I draw this arc. I put my needle on A, and I draw this arc. Then I go back and I find, pick up my compass here, my ruler. Then I go and I touch where it's crossed here and where it crossed here, and I draw that line. This is a perpendicular, because they form right angles, and it bisects it, it cuts it in half perfectly. Okay, if you probably don't have one of these at home. If you do, great. If you don't, guys, feel free to just fake draw it. In other words, with my hand, just go whoop, whoop, and cut it in half to get there. All right, now they're going to start to do these things for real. Okay, use a metric ruler to find AB and BC. Well, guys, it was 6 centimeters, and we cut it in half. So this is going to be 3 centimeters. This is going to be 3 centimeters. Where the line and the segments intersect, 4 angles are formed. What is the measure of each angle? Guys, it's perpendicular. Perpendicular means forms a right angle. Right angle means 90 degrees. Why is the line you constructed called a perpendicular bisector? Because the line is perpendicular to the segment and divides the segment in half. So perpendicular, bisect, means in half. Here's how you inscribe a square in a circle. You draw a dot on a piece of paper for the center of your circle. You set the compass to 2 centimeters. You place the pivot point on the dot and draw the circle. You use a ruler to draw a diameter. You set the compass a little wider than half the radius of the circle, so just what we did on that first page, guys. You place the pivot point on one end of the diameter, you draw the arcs, then you do the same on the other end, you construct your perpendicular bisector that we did on the front page. Now, 2 diameters divide the circle into quarters, so they went all the way here and drew those lines. 2 chords between the endpoints now create the 2 diameters, so now they go here, here, and you have inscribed your square inside a circle. Okay, so guys, there's nothing we really need to do because they're doing it all for you. Number 4 says this. Each angle of the square is an inscribed angle of the circle. What is the measure of each angle of the square? Well, guys, I don't need a protractor for that. I know that squares have 90 degrees. So they're saying this angle is 90, is 90, is 90, is 90. Okay, so guys, front side cuts it in half. Second side simply says if you drew a circle first, if I drew a circle on top of this thing, then I would connect these dots. That would give me my really ugly square because I didn't use a straight edge or a compass, guys, but that's all they're doing. Okay? Page 2. Within the square, inscribed in the circle are 4 small right triangles. 2 sides of each triangle are radii of the circle. If the radius of the circle is 2 centimeters, then A, what is the area of each small? So we're back here, guys. This is 2 and this is 2. So they're saying, what's the area of this little triangle right here? Well, 2 times 2 is 4. It's a triangle, so I cut it in half. So 2 times 2 is 4, divided by 2 is back to 2 centimeters squared. How can we find the area of the inscribed square? Add the areas of the, how many triangles do I have? I have 4 triangles. So the area of the square, 4 times 2 would be 8 centimeters squared. Awesome. That is drawing a circle, cutting it in half or bisecting it, and then putting a square inside it. Now we're going to learn how to bisect an angle. Use a protractor and a ruler to draw a 60-degree angle. So boom, they set it on there, they drew their 60-degree angle. Place the pivot point of the compass on the vertex of the angle. Draw an arc that intersects it. Label the vertex V, label where it hits R and S. Set the compass more than half the distance from R to S. Place it at R, draw an arc, do the same at S, draw an arc, make your 2 arcs intersect. Label the point T. With the ruler, draw a ray through VT. Ray VT now divides RVS into 2 congruent angles. That is an angle bisector. Okay, so they kind of showed it to you guys. They drew the thing, you drew this. Now you go down here, and what they're doing is they're taking their little mark here, and I'm going to make mine up here, and I'm just going to show you what they did. So they pick anything they want, they drew this line. Then they go out here, guys, and you just put a mark out here, and you just swing it up there. You move over here to the R, you swing it up there, and you cross it. And then you just connect V to where it crosses. And you draw your line, and you have your angle bisector. Use a protractor to measure the original angle you drew. I don't need to do that, guys. They told me to draw a 60-degree angle. Now measure the 2 smaller angles by ray VT. So now I want to know, what is this one and what is this one? Well, guys, it's a bisector. It cuts it in half. So half of 60 is 30. The other half of 60 is 30. In this activity, you constructed an angle bisector. Why is the ray called an angle bisector? Well, because the ray divides the original angle, sorry, I put another A there, into 2 congruent angles. That is the angle, the ray does what the angle in half? It divides it in half. Okay, so guys, what they're trying to teach you is, what does the word bisect mean? The word bisect means divide in half. So I'm going to divide an angle in half, and I'm going to divide a segment in half. And in geometry class, when we use this a lot, guys, we always use compasses. Some of us would say, why can't I just use my protractor, draw a 30, and then draw a 60, and then draw 2 30s in there? You certainly could. But this is exact bisectors, and it doesn't matter with the measuring of it. Okay? What's the real thing, guys? It's a second way to do math. You've been from a young age saying, can I draw a 6-inch line, and then can I draw a 3-inch line with my ruler? Yes, you can. Is there a second way to do that? Absolutely, with a compass. All right, now we have to take it to the next step. It says, can you inscribe a regular octagon in the circle? Make a compass. Use a compass and a ruler to make a circle with a diameter. You did that from the last page. Label it M in the middle. Draw XZ, your diameter. Use the diameter endpoints to make perpendicular bisectors. Remember how we did that? Little swing this way, little swing that way, cuts it, draws it. We have this diameter, what they call Y. Draw your intersecting arcs outside the circle to make Y and Z. Draw the intersecting through there. So now I'm going to go from the point Y and X, draw there. I'm going to go from Y and Z, get those marks. With the ruler, draw two lines through the points where the arcs intersect, passing through the center of the circle. So now I run my ruler from here to here, whoosh, run my ruler from here to here, whoosh, that creates this thing right there. Okay, so if I was going to show you that in step by step, I use my compass, I draw the circle. Then what we would do is go from the first page, guys. I'd make my little marks here and swing that thing. Now they did it in two small little guys, but you get that crossing. And then they're going out here. I'll make it a little smaller so it fits. I'm going out here and I'm drawing this guy like that, and then down here and drawing this guy so they cross. So I'll draw it out here because mine's a little bigger so you could see. So they just went like that. Then they moved down to the other point, went like that. That's where mine would intersect. Go down to Z, swing up here. Go down to Y, swing down here. And then if I would draw those things, guys, this is how they get that line. They just go up here and they go right through that all the way. I keep shutting my pen down. Boom. And boom. Okay, that took my circle and divided into 8 pieces of the pie you can see. So now what's the last step? Now they're just going to take their ruler and connect these dots. So they would connect dot to dot. I'm not going to use my ruler anymore so I can go a little faster for you. Dot to dot, dot to dot. Corner to corner, corner to corner, corner to corner, corner to corner, corner to corner. Boom, you have an octagon. What is the measure of each small central angle that is formed? They want the measure of this, guys. Okay, now I could put my protractor on there, or I could go like this. Hey, this is a 90-degree angle, and I just cut it in half. What's half of 90? 45 degrees. What's the other way I can do this? It forms a full circle. Full circles are 360. How many do I have? I have 8 little pieces here, and 8 goes into 360 45 times. The octagon is divided into how many congruent triangles? 8. Segments MW and MZ are radii of the same circle. Classify MWMZ by sides. So it's WMZ. Well, guys, these are radii, so they're the same length. So 2 sides are the same length. Starts with an I because 2 sides makes it isosceles. It's an isosceles triangle. So we're teaching you some of the truths as we work our way through that. Done with page 2, last little page. What is the measure of angle MWZ? What is the angle of WMZ? Well, guys, that's 45 degrees. Why? Because it's 1/8 of a circle. What's a circle? 360 degrees. What is the measure of MWZ? So now I'm going MWZ, and I'm going MZW. These guys are going to be the same length, aren't they? So circles add up to 180. I had to use 45. So I have 180 minus 45 gives me 5, gives me 3, gives me 135. I now need to take 135 and divide it in half. That goes in there 6, which is a 12, 15 is a 7, which is a 14, gives me a 1, so I have 67.5 degrees. The angles of the triangle total 180 degrees. And angle MWZ we already did is 45 degrees. So guys, they made us do all the work ahead of time to answer these questions, and now they're telling us how to do it. So MZ plus Z are equal, so each one's half of that, which is 67.5 degrees. What is the measure of YWZ? So I'm back here now. I'm going Y to W to Z. Well, guys, you just figured this out. This was 67.5. If it's 67.5 here, it's 67.5 there. So I put the two 67.5s together, and I'm back there. It's 135 degrees. YWZ is the sum of those two. They each measure 67.5 degrees. What is the measure of an inscribed angle that is formed by an octagon? Oh, it's 135 degrees. If we remember that, guys, we did this interior and exterior angle. We always did the exterior first because exterior is take 360 and divide, sorry, that's a really bad 6. Take 360 and divide by the number of sides. We're talking octagon, so we already did that, guys. That's how we got the 45. And then you just do 180 minus the 45. This is exterior, so I subtract, get 135. That's interior, because together they form a straight line. Okay, guys, bisecting cuts in half. That's what you need to know. We will not use this lesson much more in the last 20 lessons that we have. It's just a good skill to have. You use it a lot more when you get into high school, where you will use a compass and a straight edge. Now, guys, they always say straight edge. They don't call it a ruler, because if I literally wanted to, I could use my book as a straight edge. My book helps me draw straight lines. So it could be anything. That's why they're not using the term ruler. All right, investigation 10 knocked out. Have a great weekend.